Hello, welcome to the lecturer's desk. Get your medical thoughts cleared before you leave. And please don't forget to subscribe to the YouTube channel and turn on the notification bell.
Hello guys, welcome back to the lecturer's desk. My name is Mike, you can call me Mike. Today we are going to talk about how we can use the graph to determine the axis, the position, and then how to use to calculate the heart rate. Do you understand? So we're using the graph. I have our graph here, and then through this graph you will determine the axis, the position, and then the heart rate. Do you understand? Now, when we talk of the axis talk about the movement of the electrical activity throughout the heart. Do you understand? Or basically the movement of the vector. Now, the direction of the vector is where we are going to talk about, where the vector will be directing towards. Now, for these things, for this axis and then the position, you cannot just take any lead on the EKG graph and use it to determine. We have specific lists in which we use to determine the axis and the position. Do you understand? Now, if you take the axis, we use the D1 and then the D3. The D1, according to its position, it is at the left side. Do you understand? And then the D3, according to its position, you find it at the inferior right side. So basically, we find it at the right side. Do you understand? So now, the D1 will be representing the left side for us, and then the D3 will be representing the right side for us. Now, if we take the heart and then we draw a circle to it, and then we divide the circle into 4 quadrants. Let's say we have 1, 2, 3, 4. This side will be where we generate our action potential, and then the vector being generated will be transmitted to the third quadrant according to the position of the heart. The heart is positioned in a diagonal way. Do you understand? Now, when there's movement of the vector to this place, we have our D1 here and we have our D3 over here. Do you understand? Now, the vector will be moving in between the D1 and then the D3. So the resultant vector between the D1 and D3 must give a positive reading on both D1 and D3. So D1 and D3 must be both positive. Do you understand? When the vector moves towards the third quadrant. And this is what we call a normal axis. Do you understand? So the third quadrant over here, when the vector passes through the first quadrant, the third quadrant, this is where you call a normal axis. Are we clear with it? Now, let's look at a condition in which it moves to the D1 and then towards the D1 and away from from the D3. Do you understand? We say there's deviation towards the D1. And D1, from my first explanation, I said the D1 represents our left side and then the D3 represents our right side. So they will be positive at the left side and the negative at the right side. When there's D1 being positive and then D3 being negative, we say the deviation is towards the D1, which is the left. So we call it left deviation. Are we clear with it? Now, let's look at a situation where the vector will be moving towards the fourth quadrant. Do you understand? When it's moving towards the fourth quadrant and moving away from the second quadrant, which is the D1, we say it is right deviation, where the D1 is negative and then the D3 is positive. Are we clear with it? Now, let's look at a condition in which we find both D1 and then D1 and then the D3 negative. When D1 is negative and D3 is also negative, that means the vector is not what? Moving either towards this place, nor this place, nor this place. That means the vector is what? Around what? The first quadrant. And we say what? It is what? Indeterminate. That vector is what? That axis is what? Indeterminate. So we have a normal axis where the vector will be moving towards the third quadrant, where it gives a reading of positive in both D1 and D3. And then right deviation is where the vector will be moving what? Towards the fourth quadrant. Do you understand? Which gives you what? D3 a positive reading and D1 a negative reading. And you say, talk of the left deviation, where the vector will be moving towards D1, and then that's the second quadrant, giving D1 positive reading and D3 negative reading, and indeterminate when both the D1 and then D2 are negative. Do you understand? Now let's come to the graph over here. This is our graph. We take the graph, this is our D1, this is our D2, and this is what? Our D3. You take the D1, have what? A positive reading over here. D3 has what? A positive reading over here. So if we take the two, when you compare the two, they are both positive. So we say the vector is normal. Are we clear with it? Now let's come to the second graph. If we take the second graph, this is what? Our D1 and our D3. This is our D3. So taking what? The D3 and then the D1. The D1 is having what? A negative reading. Do you understand? And then the D3 is having a positive reading. If D1 has a negative, D3 has what? Positive. The vector will be moving towards D3. So we say it's what? Right deviation. Do you understand? And let's come to this graph. If we come to this graph, we have D3 having a negative reading, D3 having a negative reading, and then the D1 having a positive reading. So if D1 has a positive reading and D2 has what? D3 has a negative reading, we say the deviation is towards what? The D1, which is what? The left deviation. Are you clear with it? So we take the graph and want to read or want to identify what? The deviation of what? Of the electrical vector or the axis. Talking of what? Comparing the D1 to the D3. If both are positive, you say it's what? It's normal. Do you understand? Now, let's look at something here. Let's check possible diagnosis for the right deviation. Do you understand? When you take the right deviation, what possible diagnosis can we make? We can talk of what? The right ventricular hypertrophy. The right ventricular hypertrophy will give what? A right axis deviation. Do you understand? And then talk of what? The left posterior fascicular block. We take the left posterior fascicular block. It will give us what? The same deviation. That's the right deviation. And then we have the pulmonary what? Hypertension. And then we have what? The COPD, which is the chronic obstructive pulmonary disease. Do you understand? It also gives us what? The same deviation. And then the last two, we can talk of what? The congenital heart defect and also the cardiac arrhythmias. Are we clear with it? Now let's come to the left deviation too. For the left deviation, what can we possible diagnosis that you can think of? We can think of what? The left hypertrophy. We can think of what? The left anterior fascicular block, and also can think of what? The inferior myocardial infarction. You understand? And then the last, you can also think of what? The cardiomyopathy. So this is what? Basically what? The axis of the heart. Do you understand? Now, let's come to the position of the heart. Now, the heart is being positioned in what? In a diagonal form. Do you understand? From here to this side. It's positioned that way. And then according to the position of the heart too, we talk of we make reference to what specific lead. And what are those lead? We have what the AVL and then what the AVF. The AVL at the left side and this one is at the inferior side. Are you clear with it? Now let's look at something over here. For the position of the heart, we talk of when this one is what positive and this one also positive. When you have positive reading in AVL and then the positive reading in AVF, that means the heart is what? Intermediate. It's at the intermediate, which is a normal one. Do you understand? Now, in the condition in which we get this one positive, but this one changes to what? To negative. You understand? The heart will be shifted. It means the heart has been shifted towards what? The AVL. Do you understand? To making something like a horizontal. Are you clear with it? So if the heart will be something like this. Do you understand? Making what? Something like a horizontal. So we say we have what? The position is what? Horizontal. Are you clear with it? Now, in the condition in which the AVL is what? The negative and AVF is what? Positive. It means the heart is not in a diagonal form again. The heart is what? Shifted, forming what? A perpendicular. Do you understand? So heart is what? Basically what? A vertical one. So we say what? The position is what? Vertical. Are you clear with it? Now, aside that one, we have different or another thing that we can mention of when you take what the graph to read. For example, a condition in which this one is what? Biphasic and this one is what? Positive. We say it's what? Vertical. This one is positive, it's vertical, but that vertical is not a pure vertical. We say what? Semi-vertical. You understand? The same thing happens when this one is what? Biphasic and this one is what? Positive. In normal sense, it's supposed to be horizontal, but it's not a pure horizontal because this one is not what? A pure negative. It's what? Biphasic. So we say it's what? Semi-vertical. So we have what? Semi-vertical. We have semi-horizontal. Semi-horizontal. We have semi-horizontal, semi-vertical, vertical, horizontal, and then intermediate. The intermediate is the normal. The horizontal is where the heart is being positioned in the horizontal form, and then vertical when the heart is positioned in the vertical way, and then semi-vertical is something like vertical but not a pure vertical, and then semi-horizontal, something like a horizontal but not a pure horizontal. Now let's check that one too on the graph over here. When you take the graph, you understand, we are making reference to the position, so the AVL and then the AVF. Now here the AVL is what? Positive. They are positive over here. The AVF too is what? Positive. So we can say it is what? We can say it is at the what? At the inferior what? Part, which is what? The vertical. So from this they are both positive. So we can say it is what? Intermediate. Sorry, we can say it is what? Intermediate. So this one is positive and this one is also positive. We can say it's what? Intermediate. Are you clear with it? Now, let's look at something here. Let's check the second graph. The second graph over here, the AVL is what? Negative. And then the AVF is what? Positive. AVF is positive. And this one is negative. Do you understand? So, this one is positive and this one is negative. That means the heart is what? Vertical. So we say what? It's what? Vertical. Are you clear with it? Now, let's check this one too. The AVL is positive and then the AVF is negative. So we say the heart is what? In the horizontal form. So the heart is what? the position is what? Horizontal. Are you clear with it? Now, let me check if I can get what? The semi one. No. If I can get a graph which is what? A semi. Now, let's look at something over here. The AVL over here, when you check, the AVL is positive, but the AVF is what? Biphasic. Do you understand? Both positive and negative, which is what? Biphasic. So for the biphasic one, we say it is what? Semi-horizontal. So normal is supposed to be horizontal, but this one is a pure negative. It is both positive and negative, which is biphasic. So we say it's semi what? Horizontal. Are you clear with it? Now, so that is that for the position of the heart. And then let's come to the last point, which is what? The heart rate. Now, how can we calculate the heart rate using what? The graph. Let's look at something over here. The heart rate. We calculate it in two main ways. When the rhythm is what? Regular, and then irregular one. Are we clear with it? We have regular and then the irregular one. Now, we have different way of calculating the regular one and different way of calculating the irregular one. It's not the same way. Now, if you take the graph, our last meeting, I made mention of the small boxes and big boxes. Do you understand? If you take the small boxes, we have about 1,500 small boxes in there. And then we take the big boxes, we have about 300. Do you understand? Now, for us to know the heart rate talks about the time. Do you understand? The time and then the number of the QRS complex generated. So between one QRS complex and another QRS complex, do you understand? We count the time over there to give us what? The heart rate that we are talking about. Are you clear with it? Now, let's look at something here. When it is normal, like let me take this one for example. When it is regular means between one R and then another R wave, there's what? Equidistance between them. Are you clear with it? You take it, this one to this, to this, to that. There's what? Equidistance. That's what we call is what? It's irregular. Now let's look at the irregular one. Check this one. The distance between this and that are not the same. Here to here and here to here are not the same. So this one is what? Irregular. And this one is what? Regular. Do you understand? And also when you take this one, the distance between this and that and that and that is also the same. So that one too is what? Is regular. Do you understand? Now, for the regular, if you want to calculate the regular, whether you take 300, do you understand? And then divide it by what? The number of big boxes that are there between what? Between two R waves. So let's take this R waves. Let's take this for example. Between this R and then this R. Do you understand? Always we take it at the big line so that it will give us what? The accurate what? Counting of the boxes. Now, between this R wave and this R wave, how many boxes do you have? We have 1, 2, 3, 4. Are we clear with it? 1, 2, 3, 4. So you what? you have to divide it by what? The 4, and then you get what? The answer. Are you clear with it? Or if you like, you can also start by counting it like, if you move one box, it's 300. Another box is 150. Another box is 100. Another box is 75. So that's it. So when you get 300 divided by 4, you're going to get 75 what? Heart rate. Do you understand? 75 heart rate. If you don't like it this way, you can do it as I said. You start from one big box. When it is regular, you start from one big box, and then you move. When you move to another big box, it is what? Read as 300. When you move to another big box, it is read as 150. When you move to another big box too, it is read as 100. And then the next big box is read as 75. If it continues, another big box to read as 60, another big box as 50. Do you understand? The same as continue. But if you use this formula too, you will reach at the same point. Now, let's look at the other one too, the small boxes. So it will be 1500 divided by what? The number of what? The small box. The small boxes. You understand? So you count the small boxes. So this formula is actually entails a lot because the small boxes are somewhat difficult to count. So you cannot what? Be using that one. So basically we use what? The big box formula to do the calculation. Are you clear with it? Or when you want it fast, you start from here to here. We have 300. Do you understand? 150, 100, 75, 60. Do you understand? The same procedure, the same pattern. So you go. If you want to know, go or doing revision about it, you can be working more on what different graphs and it will stick. Do you understand? Now, this is for the regular one. Now let's come to the irregular. For the irregular, For the irregular, we use something we call the 6 seconds rule. And you can use the 10 seconds rule also. Now, why are we saying 6 seconds rule and then 10 seconds rule? Look at something over here. The formula is you take 60 seconds. Do you understand? And then you divide it by what? A certain period of time. So now, the period of time over here is what we call the 6 seconds. Do you understand? So, when you take 6 seconds, how are you going to use it to calculate for this? Do you understand? So the 6 seconds over here, we divide it by what? You divide it by what? By 60. And you are going to get what? 10. Do you understand? So anything that you get over here, you are going to multiply it by what? 10. But if you are using the 10 seconds rule, it will be what? 60 divided by what? 10, which will give what? 6. So anything you get, you are going to divide it by what? 6. Now, let's get into it so that you understand. The 6 seconds rule is when you take the 6 seconds, you know how many boxes are there in 6 seconds? In 6 seconds, one big box is 0.2. So 6 divided by 0.2 is going to give you what? It will give you what? 30 big boxes. Do you understand? Then, when you come here, we have to count. You have to count 30 big boxes. Let's start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we have our 30 to be here. Our 30 to be here. Do you understand? So within these 30 big boxes, how many small boxes are there? how many QR complex are there? Do you understand? So count what? The QR complex. So 1, 2, 3, 4, 5, 6, 7, 8. Do you understand? Now, let's come here. So for the 8 QRS complex, when you get the 8, you multiply it by what? By constant 10, which is the 60 divided by 6. Constant 10, which will give you what? 80. Which will give you what? 80. So as this one, normally the heart rate is 75, as we said, 75. When you use the 6 seconds rule, you are going to get something like 80, which is what? Very close to the normal calculation. You see, this formula can work or can be the same, can work on both regular and then the irregular one. Do you understand? This formula can work on regular and then irregular one. And it's not actually, it won't give the exact heart rate, but it will give what? The mean one, the average. This one give what? The average heart rate. Do you understand? So let's take irregular rhythm and then use it. Now let's take, when you take irregular rhythm, let's start from here. 6 seconds rule. We want 30 big boxes. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So here is what? Our 30 point. You understand? So at that point, how many R wave do we have? 1, 2, 3, 4, 5, 6, 7. So we have 7 R wave. So it will be 7 times 10, which will give us what? 70. Are you clear with it? We have what? Our 70. So this 70 is our average heart rate. This is our average heart rate. Now, we cannot use the previous formula, which is the 300 divided by number of what? The number of big boxes between what? One R wave and another R wave. Because if we take this R wave to this R wave, we have about 1, 2, 3, 4, 5, 6 boxes. When you take this R wave to another R wave, we have 1, 2, 3. So actually, we can that formula cannot work. That's why this one is what? Irregular. So for the irregular, we use what? The 6 seconds or the 10 seconds rule. You understand? So this is for the 6 seconds. Now let's talk of what? The 10 seconds. So for the 10 seconds too, what you do it, you divide this here by 10, and you are going to get here to be what? 6. You understand? Now, if you divide 10 by one small box, one big box, which is 0.2, how many are you going to get? You are going to get 50. You are going to get about what? 50 over there. Do you understand? And when you get 50 for there, let's look at something over here. When you get the 50 for here, you are going to count 50. Do you understand? Now let's do the counting over here. We ended 30 over here. So 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. We didn't actually reach the 50 points. Do you understand? So that this formula, it also works. It also works, but it also involves what? A lot of what? Work. Do you understand? So basically, we use what? The 6 seconds rule, which is what? The most fastest one to use. Do you understand? As the 300 one is the most fastest one for the regular, the 6 seconds rule is the most fastest one for the irregular. And that one too can work on the regular one. Do you understand? Now, so that is that for what? For the 6 seconds rule. I repeat, for the 6 seconds rule, first, you take 10. 10 is our constant. 10 is constant. For 6 seconds rule, 10 is constant, because when you divide 60 by 6, you get 10. 10 is constant. So getting 10 constant, you count for 30 big boxes, and within these 30 big boxes, you count for the number of R wave over there. So the number of R wave over there will be what? Will be multiplied by the 10, and then you get what? Your heart rate. So this is basically how you can what? Calculate the heart rate using what? The graph. You understand? That's when it is regular or irregular. 1. To calculate the heart rate, know it's regular or irregular, and know the formula you are going to use. Regular, whether you use the 300 formula or you use the what? The 1500 formula. And then the irregular one, whether you use the 6 seconds rule or you use the 10 seconds rule. 6 seconds rule, the constant is 10. And then you count 30 boxes, and then you check the number of R wave over there, and you multiply it by 8. So that is basically the whole class involved, or the whole class entails. So we have our axis, we have our position of the heart, and we have what? The calculation of our heart rate. If you find the class interesting, please like, share, and then comment. And then also lastly, subscribe to the channel so that we too can get what? The energy and then the motivation to continue bringing you what? More videos on medicine. Thank you for staying with me till this time. See you in my next video.